So in this video we can focus much on what you call the discriminant. So what is the discriminant? By the way, we have the general form of the quadratic equation given as ax squared, let's say, plus bx and plus c, which is equal to zero, where a, b, as well as c, these are said to be the constants. They're said to be the constants representing the real values. And whenever we are solving the quadratic equation, we end up coming up with two actually values of x, since the highest degree power is given as 2. And those actual values are said to be the roots. Other than that, they can have, let's say, x is equal to 2 or x is equal to 5. And they can have, let's say, x is equal to half, or else x is equal to, let's say, 0. It can be that, or let's say you can have x is equal to -2. You can also have x, let's say, is equal to the square root of, let's say, 2. So these are said to be the actual roots. Keep that in mind. But we have some cases where, upon solving for the quadratic equation, end up gives us, let's say, we can have, let's say, x is equal to, let's say, x is equal to 2. Also we can have x is equal to 5, and also x is equal to 5. These are the cases where the quadratic equation gives us two actually similar roots. What would you say about that particular quadratic equation? And what if we have, let's say, some cases whereby the quadratic equation gives us two dissimilar roots? Let's say x is equal to 2 and also x is equal to 5. And so you can have x is equal to -2 and x is equal to +2. Now these are said to be the dissimilar roots. So what would you say about that kind of the particular quadratic equation? The one that gives us actually two dissimilar roots. What about if we have, let's say, the quadratic equation that has no real solutions? So the one that cannot be solved actually as far as the mathematics is concerned. What would you say about that particular actually quadratic equation? So now the responses towards all these questions are based on what you call the discriminant. So what is the discriminant? And by the way, we know that one of the ways in which the quadratic equation can be solved is to use the quadratic formula. That is given as x is equal to -b plus or minus the square root of b squared minus 4ac divided by 2a. So this is what you call the quadratic actual formula. Now, if we say a discriminant, it is the expression inside the square root, and which is given as b squared minus 4ac. So this is what we call the discriminant given as g, and it is the one that determines the nature of the roots of the quadratic equation. Now this is what we call the discriminant, the one that determines the nature of the roots of the quadratic equation, in the sense that whenever the discriminant is, let's say, equal to 0, what will happen is that that particular quadratic equation will give us the two similar roots. If that's the case, then we say we say that particular quadratic equation has got one real root. That is, if the discriminant is actually equal to 0, then we say that particular quadratic equation has got one real root, because it will give us the two similar actually roots. And if it happens that the discriminant is let's say less than 0, what it means is that inside the square root will have the negative value which is undefined. Then we say that particular quadratic equation has no real solution or has no real roots, therefore cannot be solved. That is, if the discriminant is less than 0. And if the discriminant is greater than 0, what it does is that that particular quadratic equation will have two dissimilar roots. In other words, will have two roots that are different. So if that's the case, then we say that particular quadratic equation has got two distinct roots. So keep that in mind. That is to say, if the discriminant is equal to 0, what it means is that that particular quadratic equation has got the one real root, or in other words, it is having the two similar roots. And if the discriminant is less than 0, it means that particular actually the quadratic equation has no real solution. And if the discriminant is greater than 0, it means that particular quadratic equation has got two distinct roots. Keep that in mind. So which means you can only be able to determine whether the quadratic equation will give us two distinct roots or one real root or has no solution by looking at the discriminant itself. So let's have to understand about the following cases. We should have to determine whether the following equations or quadratic equations has got one real root, two distinct roots or no solution. And for the following cases, let's say you have x squared and minus 4x, that which is, let's say, equal to -4. So this is a typical quadratic actually equation, since the highest degree was given as 2, but it is not in the general order. Therefore, have to bring this -4 to this side. Now in this case, we'll have it as, that should be x squared minus 4x, let's say plus 4 is equal to 0. So for this case, we have a which is given as 1, and the b is given as -4, and the c is given as, let's say in this case, we'll have it as 4. So what is the discriminant? Now the discriminant is given as b squared minus 4ac, and it's such that we have it as -4 to the power 2 minus 4 times a, which is 1, times c, which is given as 4. In that case, we'll have it as being given as the 16 and minus 16, which is equal to 0. Now you can see that the discriminant is given as 0. Since the discriminant is given as 0, it means this particular actually a quadratic equation will have the two similar roots upon solving it. So keep that in mind. And let's say we have this kind of a case. Let's say we have x squared and say plus 3x, and we have minus 10, which is equal to 0. Now, how many roots does this actual equation is having, and what is the nature of those roots? We use what we call the discriminant, where we have a being given as 1, and the b is given as 3, and the c is given as the -10. Now the discriminant is given as b squared minus 4ac. In this case, we'll have it as 3 to the power 2 minus 4 times a, which is 1, times the -10. So in this case, we'll have it as that of, we'll have 9 and plus 40, which is the same as the 49. So now, since the discriminant is not actually, since the discriminant is greater than 0, since it is positive, it means this particular actually quadratic equation will give us two distinct roots upon having it being solved. So keep that in mind. Let's say we have this case, we should have to proceed as well. Say we have, let's say x squared, let's say plus x, and say plus, let's say 20, which is equal to 0. How many roots does this actual equation have, and what is the nature of those particular roots? So use the discriminant as well. So in this case, we have a, and which is given as 1. We have b, which is given as the actual 1 as well, and c is given as 20. And the discriminant is given as the b squared minus 4ac. So that will be given as 1 to the power 2 minus 4 times 1 times c, which is given as 20. Now have 1 minus, that should be given as, should be 80. So have negative that of 79. So now since the discriminant is less than 0, since it is negative, it means this particular actually quadratic equation has no real solution. So that's how you have to understand about the discriminant and how important it is in the determination of the nature of the roots in which the quadratic equation is actually having. And how about if we have this case? Let's say we have x squared and that's say minus 12x, and that should be which is equal to negative 16. So in this case we should have to bring this 16, negative 16 to the other side, and that to have it in the general form of the quadratic equation. So have it as x squared minus 12x plus 16, and which is equal to 0. Now using the discriminant, we need to have to understand that we have a that will be given as this. Let me have it this way. So which means we'll have a that will be given as 1, and that b that is given as the negative 12, and the c that is given as it should be a 16. Try to have it out to determine the roots in which that particular quadratic equation is having. And also try this as well. We have y squared and minus the square root of 5 times y, which is equal to negative 1. So try to understand that and up to how we should be able to have to determine whether that particular actually a quadratic equation is having one real root, two distinct, or no solution. And also try this. We have x squared, let's say, plus, that should be the square of actually 3x, and plus 3 over 4, and which is equal to 0. And also try to have this one out, and to determine how many roots or the nature of those particular roots they actually, the equation is actually having. And also have this one out as well. Let's say we have the square of 2x squared, and let's say we have plus the square of 3x, and plus 1, which is equal to 0. And of which this is the a, this is the b, and this is the c. So try to have that one out at your own time. And also think about this one as well. Let's say we have m squared over, let's say, 4. And we have minus 4m over 3. Let's say we have it as plus 16, say, over 9, which is equal to 0. You should also have to do it in the same way to determine how many roots is that one having, and what is the nature of those actual roots. Now sometimes using the concept of the discriminant, we can be able to apply the nature of that case in the following ways. Let's say we have the equation given as x squared and plus, let's say, kx, and plus 5, which is equal to 0. Now assuming that this actual equation has got the one exactly real root, it means assuming that this equation has got the one real root, which means it has got two similar roots, find the value of k that satisfies that. So if that's the case, what it means is that this equation, the discriminant, is given as actually is given as 0. So that's the essence behind, and from the fact that the equation is said to have the one real solution. So what is the a? We have it as 1. What is the b? We have it as x. And what is the c? We have it as a 5. So which means the discriminant is given as 0, which is the same as b squared minus 4ac is equal to 0, or have should be k to the power 2 minus 4 times 1 times c, which is 5, which is equal to 0. In that case, we'll have it as k squared. We have k squared minus, that should be 20, that will be equal to 0. So which means we'll have k squared that will be given as positive 20. So I have to introduce the square both sides. We'll have k is equal plus or minus the square root of 20. That is the same as the k is equal to positive the square root of 20, and the k is equal to the negative square root of 20, of which using the sides you can be able to simplify up to the square root of 20, and of which you have it as 2 root 5. So keep that in mind. And what if we have, let's say, this case, we have, let's say, x squared, and let's say plus 12x, and plus k. That should be plus k, now which is equal to 0. Now assuming that the equation has got the one real root, what is the value of k in the same way? So in this case, the discriminant, it means it's given as 0. So where we have a being given as, I should have it in this way. Don't know what's going on here, but I have a is equal to 1, and the b will be given as 12, and the c is given as, should be k. So try to have the value of k in that nature, from the fact that the equation has got exactly one real root. And let's try to understand this one as well. Let's say we have 3x squared, and say we have the square of 2, square of 2k rather, and the x, and the plus 6, which is equal to 0. Now, given that this one is having the one real root, find the value of k. So know that the a is given as 3, and the b will be given as the square of 2k, because all these are the constants. 3 as well as the k, those are constants. And we have the c that will be given as 6. So try to have it out at your own time. And from the fact that the discriminant will be given as L. And also try this as well at your own time. Let's say we have kx squared, and say plus kx, and plus 1, that will be equal to 0. And also try this one out. That's at your own time. So keep that in mind. And what if we have, let's say, this case? Let's say we have x squared, and is equal to x, and that times 3x plus 1, and minus 7, let's say 2k, let's say plus 3. Now should be this one as 3k, by the way. I should have this as the 3k. So should be 3k, right? So this is a typical quadratic equation because the highest degree was given as 2. So in this case we'll have it as, now 0 is equal to negative, now should be negative x squared, and then plus 2x, and the times 3k plus 1 minus 7, 2k, and plus 3. As you can see it here, let me have it over here. And as such that you should be able to see what is happening there. Now what is happening is we have 2k here plus 3. So in this case, we have it in the same way as being given as negative x squared, and plus 2x, and 3k, and plus 1 minus 7, now have 2k plus 3, which is given as that is equal to 0. As you can see, we have a being given as negative 1. And what is the b? And the b is given as 2 times 3k plus 1, because we are following the general form of the quadratic equation, which is ax squared plus bx plus c. So in this case, the value of b, it is given as the whole of 2 times that one. So keep that in mind. And what is the c? C is given as the whole of this one, because even k is a constant, 7, 2, 3, all those are the constants, so we'll have the whole of that one as the value of C. So try to have that one out by using the discriminant that will have the value of k, and given that the equation has got the one real root. And also try this at your own time. Let's say half x squared, that should be, let's say we have x squared, and that should be plus 2, and say times k plus 1, and that should be times x, and that plus k squared is equal to 0. So try to understand this one up too. Thank you.